In this video, we are going to talk about circular queues. Now, a circular queue is a variation of the basic queue we have discussed earlier. Just like a basic queue, in the circular queue as well, all additions need to be made from the rear and all deletions need to be made from the front. So how exactly is a circular queue different from a basic queue? Let's take an example. Let's say I have a sample queue. If this is my status of the queue, my front will be index 1 and my rear will be index 3. So, in a basic queue, if I want to add an element to the rear of the queue, I will say that the queue has become full and there is no scope to add an element to the rear end of the queue. But as we can see, there is an empty element space in the array left to be filled. In a basic queue, there is no way you can fill up this space after you have deleted this element from the front. So in a basic queue, when you try to add from the rear in this case, we will say that the queue is full and the addition is not possible, even though there still exists a space which we can fill. So how are we going to utilize the space which is available? This is where we use circular queues. So we want to utilize the deleted space in the front. So in a circular queue, we don't say that the queue is full. We say that there exists space in which I can fill my element, and we are going to wrap around the queue and say that there exists a space in the element one after the rear, which is the first element. So we are going to consider this queue as a wraparound array or something like a circle, something like this. So this is how we are considering the array. Once we have filled up the third element of the array, we can wrap around the array and go to the 0th element. So let's say I'm going to add an element 5. So when I add an element 5, what is going to happen is my array will look something like this. My rear would have shifted to 0 and my front would stay at 1. This is how it looks like in a circular representation. As you can see, the rear has gone in a circular fashion back to 0. So in this way, in a circular queue, we can utilize the maximum space that is available inside the array. Now we can see that in this case, the rear value becomes less than the value of the front. Although the value of the rear is less than the value in the front, the rear is still ahead of the front. If you can see in the circle, the rear has finished its one round and has come to the second round where it's 0. The front is still on its first round. And so we can say that although the value of the rear is less than that of the front, the position of the rear is definitely ahead of the front because it's on its second round. So now let's look at a few examples to see how the different functions of the circular queue work. So let's say I have a queue which looks like this. So we have already seen through this example what happens when the rear reaches the end of the array. We wrap it around and we begin to fill up from the beginning of the array. So that is an example which is something like this. So I want to add 5 to this. So what are the steps I must take? I want the rear to become 0. So first I will do rear plus plus. What will this give me? Rear plus plus is going to give me, from 3 it will become 4. So rear plus plus is going to give me 4. Now I would like to add an element to the fourth part of the array. But this does not exist because it is greater than the length. So now from this 4 I will want to get the number 0. So the way to do that is I am going to say rear is equal to rear plus plus mod the length of the array. Now the length of the array is 4 because it stores 4 elements. When I do this, I get 4 mod 4 and I arrive at 0. Now the next time I want to add something to an array and I have rear as 0, it will take me to rear plus plus mod length, which will give me 1 mod 4, which will return 1 itself. So this line for rear equal to 0, 1, 2, 3, it doesn't really produce a different output than rear plus plus. It is only when rear plus plus becomes 4 that the mod 4 comes into effect and we get 0. Otherwise 0 mod 4, 1 mod 4, 2 mod 4 and 3 mod 4 is equal to saying 0, 1, 2, 3. So this is one of the cases. The second case is when we want to delete from the front and the front comes to the end of the array. So let's say our queue looks something like this. I have assumed that I have deleted from the front and I've added from the rear. So right now this is what my queue looks like. So if I want to delete from the front will go to a position 4 when I do front plus plus. Essentially when I delete an element from the front, I want the front to point to the next element. The next element is not at position 4. In fact, position 4 does not even exist. So I want front to point to the next element when I am deleting this element 6. So I want the front to point to 0. So how am I going to do that? I'm going to do it using the same logic I used for resetting the rear. So I'm going to put front is equal to front plus plus mod length. In this way, when I get front as 4, I will get 4 mod 4, which will return me back to 0. This is the delete from the front operation. Now, once again, as we have done in all the other queues, When we are adding the very first element to the queue, we are going to set the front and rear from -1 to 0 and then only add the first element to the queue. Also, when we are deleting the very last element of the queue, that is, if there is only one element in the queue left and we are going to delete that one last element, and finally we are going to get an empty queue, we're going to reset the front and rear pointers to their original value, which is -1. So keeping all this in mind, let's take a look at how we are going to write the program for the different operations.